Okay, excellent. So I'm glad to see so many of you here, because clearly there aren't that many people who are afraid of EJBs, but I assume that you are terrified of EJBs, okay? But don't worry. Hopefully by the end of this presentation, you won't be so terrified. Now, I think what would be nice, actually, is that because we've got a few people here, we can actually make this a little bit more interactive, okay? So I'm going to change the styles slightly. I've got slides, I've got a script, I've got things I want to say, but let's kind of keep it a little bit more interactive, okay? And make it a little bit more fun. So I can stop and have a conversation about something if there's something that's not clear, or I can jump through something if it's a little bit obvious, okay? So first of all, let's go through my credibility statement. So that's me. I'm a Java EE consultant. I do various other things as well. That's my Twitter. And I have a blog, readlearncode.com. I often publish various things on that blog. I write books, of course, as everybody else does here. And this one is going to be published very soon, Java EE 8, only what you need to know. So only the new stuff that is in Java EE 8 is going to be published in this book. It's going to be a few hundred pages, and it's going to be published sometime next week or maybe a little bit after. So at the moment, you can go to this URL and enter your email address, and when it's ready, you'll get an email, and you can buy it if you want to or not. I published other books, Java EE Professional Design Patterns. I also do training at LinkedIn Learning, which is Lynda, for those of you who might remember Lynda. LinkedIn bought out Lynda, so I do various training on Java EE topics. So quite basic, low level. So I got an introductory course, got JAX-RS, JSONP, WebSockets, and in spring next year, I'm going to be releasing a CDI, a training course, bean validation, and Java EE design patterns. Okay. Yeah, I blog at this address, and I speak at various conferences. Now, what are we going to be talking about? So I want to kind of discuss what this presentation is all about and what it's designed to be about. I want to talk about how we got to where we are with EJBs, so how a little bit of a retrospective, talking about EJBs within the context. And also, I would like to just sort of dive a little bit deeper under the hood and look at how EJBs actually work under the hood. So I want to talk about the services that they offer. I want to talk about the different types of EJBs, and I want to talk about the anatomy. So what's actually going on underneath. Then I want to talk about the claims that are made against EJBs, or have been at various times made against this technology. Okay. Then I'm going to try and debunk those claims by presenting some evidence. So, for example, you may have found yourself in a situation where you like EJBs, you want to use them as part of your project, but there's somebody in your organization who really doesn't like them. Whether they're justified or not, perhaps they were the poor developer who had to develop with EJBs back in the good old days of J2EE and are still suffering some of the psychological consequences of having to deal with that technology at that time. And you need to present arguments in favor of using them. So I'm going to give you some arguments that you can say, hey, look, actually, EJBs are a valid technology option. And then at the end, I'm going to give you some takeaways. So while I was writing this presentation, I was thinking of alternative titles to give this. So one title I thought of was demystifying EJBs. Because I think this presentation is a little bit about breaking down some of the myths that have built up around EJBs. When I thought about the title Revisiting EJBs, because it's been some time since anybody has actually really spoken about this technology, which I don't think is a really fair given the functionality that it can impart into your project. Then I thought, well, EJBs are too complex, fake news. Well, they're not too complex. They might have been, and that's what we will see is that they were terribly complex to use, but actually now they're not. They're actually exceedingly easy. And then things got a little bit surreal, okay? An EJB ate my project. Now what this is really about is about how the perception of an EJB is heavyweight, it consumes all of your resources, it eats your project, it eats your project's resources, okay? But then I went back to my original title, Who's Afraid of EJB? Because this is really about, not about EJBs necessarily, but about the the reputation that it has undeservedly got. And it's about trying to make EJBs a little bit more friendly in terms of their sort of marketing and how they are perceived as a technology decision. Okay, so really this is, I think, is probably the most appropriate title, as it kind of does speak to some of the fears that people had, particularly if you've heard the war stories of those who have used J2E in the good old days, and they've come to you and they've said, actually, you know, EJBs are terrible. I mean, I haven't looked at them for 10 years, but they're still terrible. So this is going to be a little bit about debunking those kind of fears. But let's have a quick look at exactly where EJBs fit in. So as you know, Java EE is a collection of 30 plus specifications. So before I continue, how many people develop in Java EE? So about all of you. Okay. How many people develop in Spring? About all of you. Excellent. Now that is exactly the kind of response that I want to see, because, you know, I was here maybe 2 years ago and I asked exactly the same question. And the number of people who put their hands up to developing in Java EE was about 5%. And the number of people who developed in Spring was about 90%. So to see a nice even split between Java EE and Spring is really great. Not that I'm going to sit here and start saying bad things about Spring. Never do that, because it's an excellent framework that solves a lot of problems, and particularly Spring 5 is pretty awesome. But it's great to see that in terms of the technologies that we're using and the technology decisions that we're using, we're open to all of that's available. So the Java EE ecosystem, which as you can see is quite extensive. And when you have all of these APIs that are specification-based APIs that are guaranteed to function in the way that the specification determines that they should function, or in the most part anyway. So EJBs, as you can see, our little lonely EJB just there. The size of the box doesn't do justification to its importance within the ecosystem. I just happen to, it's much easier to draw equal-sized squares than resize them appropriately. So let's have a little bit of a retrospective about where EJBs actually came from. So in 1997, IBM drafted the first specification for EJBs. This is really where EJBs came from. In 1999, they were brought into the specification by by Sun at the time, as EJB 1.1. Later on, in 2001, it was enhanced to EJB 2.0, okay, in J2E 1.3. Now, this is where things started to get a little bit ugly, okay? In 2003, by this time, in 2003, people who had been developing with EJBs had pretty much had all they can take of EJBs. 2 years of dealing with EJBs, 2 years of remote interfaces, of local interfaces, of the pain that comes with the XML configurations that were needed in order to create EJBs. By this time, people are pretty much sick of EJBs. And it was in this year that Rod Johnson released his Spring framework under the Apache 2 license. And in his book, Expert One-on-One J2E Design Development, he argued that J2E applications were slow, complex, and time-consuming to develop. Now, although instead of suggesting that this was actually an issue with enterprise Java, he said that this was really an issue with the way in which J2E was being used at the time, which I think is a very important point as we go through this presentation, to think it's not the technology that is at fault necessarily in many of these cases, it's actually the way it is being used. So this comes down again to education and understanding. Then in 2006, we saw EJB 3, and this is kind of where we more or less are at the moment. This is the current, or more or less the current incarnation. And this release saw a watershed moment in the development of EJBs. This is when the programming model of enterprise Java really changed from what was effectively an XML-based descriptor file type system into an annotation-driven. So all the XML files went out and were replaced by a more modern programming technology, and using much more annotations to drive the configuration. And in general, there was a substantial improvement in the ease by which one could develop EJBs and Java EE in general. So then came 2009, we got a minor update to 3.1. This is when we saw a new lightweight EJB version, EJB Lite, which could be used in the web tier. And then finally, where we are now is EJB 3.2, and there's a minor update to the 0.2 release, and it's also in Java EE8 as well, is using EJB 3.2. So that gives us a little bit of a retrospective of where we have come from. So yeah, as you know, EJBs, they are used at the business tier. So in a typical three-tiered architecture, they're right bang smack in the middle in the business layer. Okay, this is a very oversimplified diagram, but the point that I want to make here is that EJBs are right in the center, and they need certain services to do their business. You know, they're responsible for executing the business logic. So they need transactions, they need security, they need pooling, they need a whole range of services to do their job properly. Okay, and that's where EJBs sit. So essentially, what is an EJB? Do you all know what an EJB is? Yeah, I know you do, Ivor. All right, okay. So essentially, an EJB is a plain old Java object with fields and methods that implement business logic. Okay. The developer adds certain services by adding certain annotations. So services, which I will talk about in a moment, are added through the addition of annotations. So it's a POJO with annotations, and there are various annotations that add certain services. So we have a stateless annotation that makes your EJB stateless. Okay, and we'll look at that a little bit later. Another one that makes your EJB stateful. Okay, it can maintain state for the thread. We have a singleton, which is a singleton. We have one single instance of a singleton in a JVM. And we have the annotation message driven. There's a little bit more to it than just that. That gives your EJB messaging capabilities. On top of that, when you add those annotations, you get a series of services, plus you get a series of default configurations, okay? Sensible configurations. So you get thread safety by default, okay? You get pooling by default. Just by having one of those annotations on your EJB, you get these two services. You also get transactional services, just by annotating with just one of those annotations. And there are more services that you get. I'll have a look at those later, but this is just a taster. But there are optional services. Okay, there are default services which you get anyway, and then there are services which you can then choose to add to flavor your EJB. So, for example, scheduling. You can schedule your EJB to execute a method based upon some kind of cron annotation, some kind of cron semantics. You have remoting. You can make your EJB remotely accessible if you want to. And then you have web services, for example, JAX-RS. You can make your EJB a RESTful endpoint. But also, on top of that, you can fine-grain the configuration of each of those services. So if you're not happy with the default, and you want to add different types of transactional management, or you want to add, you want to configure the way it does remoting and various other configurations, you can do so. You're not stuck with the default configurations. So you have a reasonable amount of control over the behavior of your EJB. Let's dive deeper and have a look at all the services. So I'm going to go through these services now. Pooling. Now, pooling is one of the, in my opinion, the most interesting services you get for free with EJBs. Now, the way this works is that the container creates a pool of EJB instances that are shared among all of the clients. Now, upon a client request, an instance is retrieved from the pool and made available to the client via a proxy. We'll talk a little bit about this proxy process later. When the client has finished with the object, it gets returned to the pool and is ready for reuse. And the object is only created once when the pool is initialized, and it is only marked for garbage collection when the pool is destroyed. Now, the normal benefits you get with pooling in general, when you use some kind of pooling mechanism within your application, maybe you're pooling database connections, you get with this, okay? So you have good memory management and you have good efficiency. You also get thread safety, as I mentioned before. Now, this is a consequence, essentially, of having pooling. Now, if you only have, if for each request you get a separate instance from the pool, then by default, you also get thread safety. Okay. Transactions, as I said, again, whenever you call a method on an EJB, you get a transaction gets started, it remains open until the method finishes. So you get that service by default. You can configure the transactional behavior. You can open a transaction, you can close a transaction, you can create a new transaction. You have the normal transactional behavior that you would expect. So if you've used transactions with Spring, they look pretty similar to the way in which you would annotate transactions in EJBs. You have memory management. So memory management really is about monitoring the usage of your instances and storing them to disk when they're not being used, and then waking them up again when you need to use them. So memory management is taken care of by the container. Now, these are all container services. These are services that come with your container. They're there anyway. Whether you use them or not, they're there. But why not use them? So this memory management, this is called passivization, will make your instances go to sleep while they're not being used and then wake them up again. This again allows you to manage the memory usage in your container. State management, again, the container manages the state management of your EJBs. So you don't have to. You don't have to write plumbing code. And a large percentage of what I'm talking about really is reducing to zero the amount of plumbing code that you actually need to write. You don't need to write state management code. You don't need to write thread safety code. You don't need to annotate anything synchronize. Okay? You don't need to do that. You don't need to create your own pool. These are all services that are there in the container, free for you to use when you want to. And I'll qualify the word free later. Optional services. Now, these are services that you gain by adding annotations to methods or classes. So security. Again, security is added with a few annotations and maybe some XML configuration, depending on your setup. Interceptors, again, you can add this as a service. This is an optional service. You also have scheduling, which I've mentioned before. This is, again, another service which you can add to your methods that allow you to execute a method based upon a cron, cron expression. Remoting. If you want your EJBs to be accessed remotely, that can be done. Again, it's an additional service. You need one single annotation to make your EJB remotely accessible. And you have asynchronous processing. So by default, methods are called synchronously, but again, you can make them asynchronous. And there are more additional interesting sort of bits and pieces. Oh, sorry, there it is. Messaging. I forgot messaging. So yeah, with again, you can make your EJBs capable of participating in messaging logic. Okay, simply annotate appropriately the EJB, and your EJB can participate in messaging. And of course, it's transactional. Okay, it's transactional messaging. Oh, sorry. Yeah, sorry. And web services. Sorry, my slides are not updating quickly enough. Oh yeah, and web services. So yes, you can make your EJB a RESTful endpoint, or if you like SOAP, you can also make it do SOAPy things. So let's have a look at how EJBs work under the hood. So here we have a class that is injecting an EJB, an instance of an EJB. So here we have the stock resource EJB instance. And the way that it works is that when you inject an EJB into your class, you don't actually get an instance of the EJB itself. You get a proxy to that instance, okay? Like this. So we're essentially injecting, or what the container does, it injects a proxy version of your EJB. And as you know, the general way in which proxies work is that they mimic the methods of the bean, and this is what they do. So this proxy bean has all the same methods that your stock resource bean has. So what happens here is when a method on the proxy is evoked, the container gets the real bean from the pool, then evokes the real method and sends the response back to the caller. Okay, so as you can see here, it retrieves the instance, the proxy from the pool. It resolves to the pool. It gets the real instance, calls the method, and sends the result back. Now, it is designed this way so that all those additional services I spoke about earlier can be evoked. And this is where they're evoked, here, in between the proxy and the real instance. Okay. Now, so for example, you provoke a method on the proxy. Okay. The transaction services are applied, and then the real method is evoked on the real instance, and then it goes back up the call chain. So this is how you get all of those services for free. In effect, effectively, in most cases, they are sandwiched between the proxy and the real instance. And this is where you get all these lovely services. I've only listed a few there, but this is where you get all those services, either for free or because you have annotated the class appropriately. So we have a singleton, we have stateful, we have stateless. For a singleton instance, there is only one instance per JVM. Okay? All proxies point to that one instance. Now, a singleton has all kinds of special services, such as synchronization, locking, and some interesting startup behavior as well. A stateless session bean actually has multiple instances, okay, that are all pooled and equal to the number of instances determined by configuration setting in the container. And you can change that configuration setting. So for example, imagine you've configured it to have 10,000 instances in your container. And you suddenly get a surge in requests for that bean for some reason. You're in a web application and you suddenly get the massive surge. It will serve those 10,000 instances, and when it gets to the 10,000th instance, or the 10,001 instance, it will queue the requests. Okay? This is a very useful feature because it allows you to throttle and control the way in which your backend resources are utilized. So you get to the 10,001 request, it's queued, and then when an instance is available, it gets served. Okay. And for a stateful bean, you get one instance per request. So per thread, you get a single instance. So let's have a look at some of the claims that are made against EJBs. So EJBs are time-consuming to develop. Well, okay, this may have been the truth many, many, many years ago. And as you may know from your own experiences or from hearing other people's war stories from that time, to create an EJB, you need to have multiple interfaces. You need to implement those interfaces. You need to have XML descriptor files. Now, there are still people who really feel who really still seem to be suffering from the way things used to be. And at that time, when Spring came out, many people moved into Spring because of the horror of EJBs and Java J2E in general. And many people have just stuck with that. I mean, obviously, we use the technology that we know the most. So if you've been developing Spring for the last 10 years, you're going to be doing that now. Another claim that is made is that it's just too complicated. EJBs are just too complicated to learn. And when you look at the specification, which is 465 pages long, you can understand why people look at that and go, you know what, I'm not reading that. I've got better things to do in my life than spend my weekends reading 465 pages specification, which is written in specification language, which is a little bit dry. Okay, I've read specifications from the beginning to the end, and if you're having problems sleeping at night, it's a pretty good solution. EJBs have a large overhead. They're inefficient. They're heavyweight. Well, for a number of reasons, this claim has been made. In fact, this is a criticism that is often levied against enterprise Java as a whole. And I want to point you to something very interesting later on when I get to debunk this, that will prove this is totally inaccurate. Lifecycle mismatches. Okay, so there are claims that are being made that the CDI scopes don't match well with EJB lifecycles. Okay, well, I'll have a look at that claim in a moment as well, and there are a few points to be made on that. Entity bean container managed persistence. Anybody happy about entity beans? You look very unhappy about them. Okay. That's fine. I perfectly understand. Let's move on to the next one. Unfashionable. EJBs are unfashionable. Yeah. How many times have I heard that? As if that was an argument for not using a technology. Because you know what? We're really fashionable guys here. We really care about fashion. So let's have a look at the first one. Time consuming to develop. Well, we've actually seen already that that is not necessarily the case. But let's have a look. EJB 2.0 required you to implement the EJB home interface and the EJB object interface, and you needed to implement a session bean interface, and then you needed to tie everything together with an EJB jar XML. You know, this is what you needed to do in EJB 2.0, just for one single EJB. And now, you know what? It's not surprising that everybody ran away to Spring, because if you look at this, you're going to do the same thing. You know, I looked at this and I thought, you know what? I'm glad they're paying me to do this, because I would not do this for free. And one mark of a good technology is, do you want to do this in your spare time? You know, if you want to program in a technology in your spare time and no one's paying you to do it, then that's probably a pretty good technology. You know, if they have to pay you to do it, effectively bribe you, then perhaps you're not using the right technology. Well, that's my point of view anyway. But now we have EJB 3.0, and look at this. This is beautiful. How many interfaces do you see here? How many XML files do you see here? None. There's none. All you see are some lovely annotations, and even more annotations than perhaps you might even need in the majority of cases. Because in order to make your EJB remote, you just throw on a remote annotation, and now it's available remotely. If you don't want to use your EJB remotely, you don't even need to have either one of those two annotations. You know, you have just stateless or stateful or whatever, and your annotation is available in your application with all of those lovely, lovely services that you get for free when you develop with EJBs. So time consuming? I don't know. How time consuming is it to type one annotation? If you don't have enough time to do that, then you need to reconsider a lot of things. So, too complex and too hard to learn. Well, if you want to sit down and read through the specification, all 465 pages over 20 chapters, then be my guest. You know, there are people who have that level of attention that they can do that. I personally do not at all have the attention span to go through the entire specification. What I do have time to do is to read the bits that are relevant to me. Okay, now in my project, I'm not going to use every single service. I'm not going to use every single annotation. I'm going to use the one that makes sense for me. Okay, so I'm just going to read the bits that I want to. And because of the way that the specification, or the way that EJBs use convention over configuration, in the majority of cases, and certainly in simple cases, you don't really need to read the specification at all. I mean, okay, perhaps I shouldn't be saying don't read the specification. I should be saying read the specification. But we all have jobs to do, and we've got to get stuff done before Friday because we want to get out on time because we have lives outside of work. So you don't always need to know exactly what's going on. You just need to get it done. And if it passes the test, then great, let's go. Let's get on with stuff. But there are plenty of learning resources out there, you know? Plenty of learning resources. Here's some books, you know? These are great books. Look, this one, Reza wrote this one. Okay? It's a really good book. I don't think I wrote any of the other ones, but this one's a good book as well, the Head First book. You know, this explains things really well. And this one as well. This one, I recommend this one. But if you don't like reading, watch a course, okay? Go to LinkedIn Learning. I've got some courses on there, so obviously I'm biased, but there are courses, lots of excellent courses on Pluralsight, okay? By Antonio Concalves, has a really good selection of courses, okay? And it's not an expensive site to join either. And of course, if you don't have any money or your company refuses to pay for your resources, well, change company, but you have YouTube, okay? There are plenty of free resources on YouTube. So just go to YouTube, find some training, find some courses. There are no excuses for not knowing how to use any technology, not really, because the amount of resources that are available out there are quite substantial, okay? Books, videos, training courses, blog articles, there's so much information out there. So learning how to use EJBs should not be hard, it should not be complicated. You can do it. Large, overhead, inefficient, heavyweight. Okay, what the hell does that mean? What do these terms actually really mean? How do you determine what is an overhead or what is a large overhead? How do you determine if something is inefficient, if it's heavyweight? I mean, these are terms that don't really have solid definitions that everybody agrees upon. I've had conversations with people that say, X is heavyweight, and then another person says, well, actually, no, X is lightweight. Again, it all depends very much about context. Now, I'm going to answer this question by relying heavily on sources from the community. Okay, when I say sources from the community, who I'm really talking about is this guy, all right? So I don't know if you saw his presentation at Java 1. His presentation entitled Java EE Heavyweight or Lightweight Mythbusters, okay? This is available on YouTube, so if you want to watch it, I will put up the link at the end of the presentation. Now, in his presentation, he demonstrated that using, he demonstrated with Visual VM that for a deployed web application that uses CDI and EJBs, that EJBs are among the least expensive in terms of CPU cycles compared with the other running processes. In fact, it was shown to be 0.1%. The overhead is so small that in an application that has a web layer, the EJB has an overhead of less than 1%, 0.1%, as I said, and the most expensive thread actually are the HTTP services themselves, as you would expect, because a lot of work is done in that layer. And then when compared to CDIs, EJBs actually outperform CDI managed beans, or CDI beans. This is a screenshot from the YouTube video. So if you watch the YouTube video, you'll see this, okay? And I thank Adam for the work that he's done to demonstrate this. So EJBs achieve far more operations per second than CDI. This is what he demonstrated. And he used something called JMH benchmarking tool. Now, it's just a benchmarking tool, and demonstrated that EJBs perform 35% better than CDI. Okay, this is benchmarking, and we can all pick holes in benchmarking, but this is an important point that I want to revisit later on. And the reason being is because of pooling. Okay, now I mentioned earlier, you get pooling for free. Every time you annotate your EJB stateless, you get pooling for free. It happens, it's just there. It's part of the services that you get. And because of that, you get this effect. You get this benefit of pooling, because what you're doing is you're retrieving an instance from a pool. You're not creating it every single time. Again, let's have a look at somebody else. Pavel did something very interesting. And have a look at this GitHub repository, because this contains the code. And he demonstrated again that actually CDI, EJBs outperform CDI and Spring. Okay, so again, you can test this for yourself. Don't just believe anything that I say, because I could just be lying to you. I'm not, but find out for yourself. Don't believe people just because they tell you something is true, that is true. Go to this GitHub repository, which I'll put up at the end of the presentation again, and check it out for yourself. Run it yourself. Do your own benchmarking. lifecycle mismatch between CDI and EJB. So EJB lifecycles and CDI scopes are not compatible. Well, this is not really necessarily true. You can line up the singleton annotation with the application scoped annotation. The singleton actually gives you more services than the application scope gives you, in the sense that it's synchronized, it's got locking, it's got interesting startup behaviors, okay? But it's essentially the same contract. You have one instance in the JVM. Stateful scopes can be mapped to session scopes, as in CDI, more or less. And stateless beans are best matched to request scope beans, okay? As for each thread, you have a new stateless bean for that particular scope. However, there is another argument, and that is that on top of this, scopes could be better aligned between CDI and EJB. Okay, I will give you that. Things are not perfect, but this is not as dramatic as you might think. And with some skillful programming, you can actually overcome any issues this might pose. Entity bean, container managed persistence. Well, they're hardly used these days. Anybody using entity beans right now? Entity beans. And not entity, not at entity, but entity beans, container managed persistence. Anybody? You can tell me. I promise I won't tell anyone. Okay, I'm sure there's one of you. I'm sure there's one of you there. I'm sure there's one of you. All right, so yeah. Essentially, the problem with entity beans is that it is what happens when you try to innovate within a standards organization. Now, some clever people at the standards organization comes up with this wonderful, amazing idea which nobody asked for. Okay, sounds great on paper. They put the effort into making it. It's developed. It's there, but nobody really actually asked for it. You know, and standards organizations should be, in my opinion, and from now on, I understand they will be community driven. With E4J, we will see less of this. In fact, we'll see none of this. What we will see is, and this is my hope, the community driving features for enterprise Java. So we won't come up against another entity bean or container managed persistence ever again. Okay? So EJBs are unfashionable. Well, yeah, okay. So what? They're unfashionable. So am I. Look at me. You know. So it's not really an issue. And it's not a reason to reject using a technology is just because it's unfashionable. That is not a justification for not using a technology. But do your own research. You know, figure it out for yourselves. You know, do your own benchmarking. There are benchmarking tools. If you watch those two videos I mentioned earlier, there are benchmarking tools that you can use very simply, very quickly, very easily that tests out your use cases. You know, don't just do something because you, or not do something because of the reputation of a technology, or because someone has told you it's wrong, or because people are laughing at you because you said, hey, let's use EJBs for this project. Haha, no, you're crazy. You want to use EJBs? They're terrible. No, do your own research. Figure it out for yourselves. Do some benchmarking and say, hey, look, I've got proof that actually this technology is going to work for our use case. What have you got? Reputation? Opinion? I don't want opinion. I want facts. I want proof. And that is what will get your argument put forward. So present your own argument and present it with evidence. Okay? Don't just follow the crowd. So, takeaways. So hopefully I have got across to you, if you weren't already there, that EJBs really are not the monster they might seem to be or might have been thought to be. Okay? They actually offer an extensive range of services at very, very low cost. As we have seen, I've presented benchmarking evidence that they are low cost. Lower cost than perhaps other alternatives. And they're easy to learn. They're not difficult. It's not a tricky technology. There's a lot to learn. There's quantity, but it's not difficult. And you have the resources available for you. You have an entire community behind you, an entire community providing you with support. And you know what? If you have a problem using an EJB or using any technology, just ask somebody who knows more than you. And you'll find that actually, if it's an intelligent enough question, they will come back and say, you know what? I'm going to help you out with this. The Java community, and I think we're really lucky in our Java community, is that we're pretty nice guys and girls, okay? We take care of each other, we look out for each other, and we help each other out. And there's a lot of people supporting and contributing to the community for free and spending an awful lot of time helping out others by developing technologies, helping out with the specifications. Some of you may be members of JCP, you may be on the specifications. You get involved so much in the community, and there are so many people there willing to help you out. You know, there's not a lot of big egos out there. So EJBs are not monsters, okay? They really are actually quite lovely to use, and they offer so much more, and they just don't deserve the terrible reputation that they've been given, okay? So be nice to your EJB. Don't abuse him. But in fact, this presentation is not just about EJBs. Okay? It's about the way we make technical decisions. Okay? A technology's reputation and negative marketing has a substantial impact over the choices we make. And this can lead us down the wrong path, or at least not the best path. So my recommendation to you is to make your own decisions and do benchmarking. Test it for yourself, and don't just follow the crowd. So don't be afraid of the EJB, and don't be afraid to stand up and stand out. Thank you. These are the links. This one here is the Java E presentation. This is a must-see for everybody in this room, so get your cameras out and photo this. This here also is an excellent video, also by Adam. So these two, excellent. This one here is the GitHub that I mentioned earlier that you can just check out and run yourself to see for yourself. Like I said before, don't simply follow what I say. Check it out for yourself and present your own evidence. So that's it from me. I hope you've enjoyed my talk. Thank you for coming, and enjoy the rest of the conference. If you have any questions, come and find me later. I think it's now lunchtime, so I'm not going to hold you up from your food, so you can go. If you have any questions, stay here, and I'll try and help you out. Thank you.